now? Yes. Okay, so my name is Victor Gонzalez, and I work in a university in the Dominican Republic. Do you know where that is? Yes. It's in the Caribbean. It's a country in an island, and that island has two countries, the Dominican Republic and Haiti. It's in the south of the U.S., like near Cuba. Maybe you know where Cuba is, right? We're like right next to them. And we're a small island, right? So we are still developing. So this type of things are not that very popular there, and we are starting to develop those things. I do not come from the side of GIS. I come from information system, and my specialty is in data analysis. So because the different projects we're working in my university, then I started working with spatial data and with the concept of smart city. So before or through the presentation, I want to start with what data is, and then what spatial data is, what smart city is, and then the projects we're working on. Maybe all of this is very basic for you, and you already know it, but So data basically are measurements of whatever we want to analyze. Right, and data is our facts and statistics that are collected so we can get information out of it. So data alone do not provide us like any meaning. It's when we interpret the data that we can get the information and the meaning of what we're seeing. So the analysis of the data is the information. And data can be of anything. Right, we have geographical data, which is your expertise. But we also have data that comes from the financial aspects, or from the human, the genome, or from the transport. And the important thing is that we have to collect data. Right? We have to measure the data, and once we measure it, then we collect it. And that data that is collected, then we can analyze. And from that analysis, then we can provide any type of information that we are looking for. Right? And data is something that it depends from where you're looking at it. It can be the raw data, or it can be already processed data. So for example, I like to think, if we're making a sandwich, right, the ingredients can be the data. So what are the ingredients of a sandwich, right? We have bread, we have cheese, we have ham, right? And we can see all those things as data. But are they raw data? Are they the raw ingredients for a sandwich? Right? Like a bread has in itself ingredients and a process to become a bread. So for making bread, you have to have flour, water, yeast, salt. Right? And it's the process of that makes the bread. So like say, for example, if we're seeing the system as a sandwich, the raw data are the bread, the cheese, the ham, right? But bread itself is not a raw data. It comes through a process. So, when we are seeing the data entering a system, that data can come from a previous system, right? And when we are trying to analyze this, then we have to figure out like what type of data we're having, like what is the quality of the data, and that is very important because if we to our system enter bad data, right, then the output is not going to be something nice. So we have to think the data can come from the rawest part or can come from another system. But the data itself and how we gather the data is the most technical aspect of, right, it will be like the most engineering part. But once you have the data and you have to share it with your colleagues or with other people, then you have to start thinking in other aspects of the data, which are like the license that the data is going to have and the amount of data. So here you have a data spectrum of how the data can be shared from a very closed environment to an open environment. This is not something that is black or white. It's a grayscale, right? And you can have something that is only available for certain people inside of an institution, or you can have data that is accessible by anybody in the world. right? And determining this is very important because it's going to let people know, like, if that data can be used. You know, like gathering data is not cheap. Sometimes it's very expensive to produce the data. And then you as an individual who's producing the data, you might have one function for that data, right? But maybe somebody else needs that data, but you don't share it, so they have to produce it again. And then you are investing the same amount of money to produce the same data once again. Right? And these are things that are beyond the aspects of technical aspect of measuring data or gathering the data. This is something that starts seeing from an economical point of view, like how can we share the cost of creating that data. So from here we can see that the data itself has a lot of components that surround it. And the technical part is basically where I am more involved in. And it's how we measure, how we gather the data, how we process it. But there's other parts like the politics, the operational, the economic, the legal. We already talked a little bit of how you share it, and the social. Here we can see like different components that affect that data. So for example, from the legal point of view, it's like what type of licenses you're using for sharing the data. Is it a proprietary license where only you and an exclusive group can use it, or an open access? And if it's an open access, then what type of requirement those who are using the data have? For example, you can have it open that anybody can do whatever they want. Or you can have it open that they can do whatever they want, but they have to tell people where they got it from. So you have different type of schemes. From the political point of view, this is not only from politicians in the government. For example, if we think about a coffee shop, and we have an owners in the coffee shop, do they want to gather data about what coffees they're selling? You know, so like for example, if we see it let's say in the university, do the president of the university wants to gather data from the functioning of the university? Or from the politicians, do they want to get data? And so the political aspect is how like the management of an institution thinks on the importance of data. The social aspect is what the individual do with the data that is being created by, let's say, an institution. So for example, if we're going back to the coffee shop, do the customers want to know or want to use the data that has the coffee shop about them? Like for example, Facebook, right? Has a lot of information or data about each individual person who uses Facebook. Have you ever tried to see what information they have about you? Have you tried to use it? Maybe to know yourself better. Right? Because we know that probably Facebook knows us better than we know ourselves. Right? So like the social aspect is regarding like, does the customer or those who are being served or are being taken as subjects for the data, are they interested to have access back to the data, or can they have the knowledge to use that data for something? The economical part we briefly talk is how, like what can you bring money-wise out of the data? So for example, can the coffee shop use the data to exploit the system and make more money? You know, so what value, money worth, is coming back from the use of data? And then you have like the institutional and the operational, which basically is how you are presenting the data and how the institution itself provides access to the data. And then the technical aspect is regarding how you measure and you gather the information and how you publish it. As I mentioned, this is the part, the technical part is where I feel more better with, right? And like this is where I work. And the other aspects, you know, like when we are talking about a data initiative project, we have people from different sides of academia, right? And we all gather together and we discuss these terms, but where I really focus is in the technical part. And here is like how you put the data available for others to access. And in this it's going to depend, like this is regardless if the data is open to everybody or closed for a small group. Because even if it's closed for a small group, right, you have to have the data in a server and people have to have access to the data. So basically you have a platform for sharing the data, and in that platform you have three important things. First is the data catalog, where all the data and all the information about the data is published. And we're going to talk more in detail about this. Then you have what is the support forum and the training materials. So the important thing about the training materials is not everybody has the same capabilities. So some people they don't need any training and they can just access the data and do whatever they want or whatever they think of with the data. But the thing is that when we try to let anybody access the data, then we have to make sure that those who do not have the technical capability can develop it and use our data. So that's what the importance of the training material is. Another thing, even if it's a close group of people who can access the data, then when you have a new person in the team, you want him to be able to start working as fast as possible, right? But without having downtime from the previous members. So the training material can help that person understand the data much faster and start producing without interrupting the work of the other persons. As well, the support forum is a way to support those who do not have the same capabilities. And the support forum can be as broad as you have somebody special from the institution or like providing the support, or you have the whole community providing support to each other. So this is going to depend a lot of what your philosophy on openness can be. And if you're like very open and you want everybody to data, then you would allow the community to support itself in developing the skills. So when anybody has a problem with one of your data sets and they enter the support forum, another user can answer his questions. Not only, let's say, like the technical person from the institution. And then when we see the data catalog, what we have to have in this data catalog is the data access, like access to all the different data sets that are published, the search capabilities so we can find those data sets, that the data is machine readable so that we can create processes with like computers and not only with humans. And the metadata is going to help the machine readable data. The license so that people know like what type of requirements are being given if you access and you gather and you use that data. The programming interfaces that you can have, like how easy it can be just that you don't have to download it, maybe you can just access it through the API. And the security, because even if the data is being given to everybody, you have to make sure that that data is not being changed by somebody else. So security is a very important aspect of data, because first, if you don't want to share it, then the security is going to help you not allow other people to access it. But if you do want to share it, then you have to make sure that people who are accessing that data are accessing the correct data, right? And it was not manipulated by a third party. So all of this are inside of the security aspect of data. If we see the architecture of a data catalog, like we have a very simple architecture where you have, let's say, in one server, the web and the file server. And here you have, let's say, all the data catalog and the data sets as a one server, as a one service. And then accessing to that server, you have, let's say, like what the websites are and like the different services that are, the different applications that are using your service. And this is a very simple architecture, especially when you're starting, like publishing data. But it's not something efficient when your data sets or your data catalogs are big. And if we see it from an institutional point of view, from a big institution, or let's say from the government, this type of architecture, you couldn't use it. So you have something where you start separating the data catalog from the data files or the data sets itself. And here you're providing a little bit more security about accessing your data set, because the only access you're going to have to the data sets and to the data files is through the data catalog. So everybody connects to the data catalog, and then the data catalog connects to the data sets. So you are decentralizing a little bit the architecture of how your files are being kept. And it will work similar where all the applications that need your service will connect to your data catalog, and then your data catalog is the one who's going to connect to your data files. And this is a little bit better for when you have bigger catalogs and bigger data sets. But still, when we are talking about, let's say, one institution, then this probably is going to work. But if we want to, let's say, merge different data catalogs and different data sets from multiple institutions, then this is not appropriate. And you would have more an architecture like this one, where you have a centralized data catalog, and that centralized data catalog connects to data sets or data catalogs in other institutions. So this is a complete decentralized system. Well, not complete, but more decentralized system, where that main data catalog is going to point to all the available data sets that are being part of that data catalog. So imagine, let's say, that the government wants to publish all the data they have, right? And the government is built by multiple ministries, right? So each ministry probably has its own data catalog, but the ministry itself has a lot of departments where each of them has their own data catalog. So what the government would do would be to create one data catalog that points to all the data catalogs of all the ministries and so on. So from one place you can access all the data sets from the whole government. And if one system goes down, it doesn't affect the others unless the main data catalog goes down. So this is a more efficient way or architecture for like big data catalogs and data sets. And we're talking about what is considered now like big data, right? Where you have a huge amount of data. So if you are willing to publish it as an institution, then you would use this type of architecture. But for this to be possible, you have to have something that is called metadata. Anybody knows what that is? So we're talking that data has to be able to be accessed and to be searchable, right? But how can you search it if you don't know what a specific data set is? You know, when you see, for example, a data set of the temperature in the university, right? The temperature is going to be like 19 degrees, whatever, right? What do you know? How do you know where it's from? Or where was it gathered? Or what year was it gathered? You know, so like the metadata is going to be data that is describing that data set. So like, for example, if we are measuring temperature in the university, part of the metadata is going to tell us that we're measuring in Celsius, right? And not in Fahrenheit. Because someone from the States, right? They don't think temperature is being measured in Celsius, right? But if they access that data, they have to know that it's not taken in Fahrenheit, that it's taken in Celsius, right? So those are the type of descriptions that you're going to give to that data set. Because in the data set, you're just going to have some numbers. You're not going to have the measuring that it was in Celsius, right? So those descriptions of the data are published in the metadata, right? And those things are like, for example, important things about metadata can be like what method you're using for acquiring the temperature, for measuring the temperature, right? That's something that, depending on the application, is important. So the metadata has to be machine readable, so like you can, because at the end what we're pushing, right, is so that machines can communicate between each other and can share the data. right? And they have to be able to understand what type of data they're using. So that's why we talk it has to be machine readable. And it has to be descriptive, both for the machine and for the humans. So you have to specify like what it's measuring on, when it was measured, how it was measured. It has to provide as much detail as it can. And for example, if we are using, let's say, the temperature for making a temperature map, right? Then we have to have the geolocation of where we're measuring, right? So like for example, the metadata will specify, let's say, the city where it is. Not because you don't have that data, but so when you're searching, you don't go like, it's easier to look for Sofia than to look for the coordinates of this city, right? So the use of the metadata is so that we're able to search for that data set, so that we can manage that data set, so we can have access control, so like we can know like who can access, who cannot access. So we can use and reuse the data, and for long-term preservation of that data set. Imagine who uses Netflix here. Netflix. Everybody use it? No? Any video streaming service? Or well, so like if you go to the library, right, and you're looking for a book, they're going to have different information about that book. They're going to let you know what language that book is, right? Is it like fiction or non-fiction? If you're looking for, let's say, scientific text, it's going to tell you the area. Is it like geographic? Is it physics? Is it math, right? And when you go to the library, then you see like all the math things are there, and they are in Bulgarian, right? So like those are metadata. Metadata is not something that was developed for information, for like this type of data. It's something that has been used for a very long time. And like the libraries are one of the first, has used metadata for a very long time. And when we talk about data, something very important is about the quality of the data. And we're seeing quality in this point from a statistic point of view. And then for measuring the quality of the data, we have 6 important aspects. And the first is the relevance of the data, how useful that data is for a user. And we have to consider that the usefulness is going to depend on who the user is. So for example, if we talk about the temperature in Sofia, it might be very useful for those who live in Sofia, but for people who live in the Dominican Republic, that's useless, right? In their day-to-day. So like usefulness is going to be very dependent on the user who's gathering. So the quality is going to be dependent on who's using that data. Then the accuracy and reliability of how you got that data, and that's how the degree of error. So for example, if we have a temperature sensor, right, like we have different sensors that can measure the temperature to different levels. So you can, for 1 degree of Celsius or for 0.1 degree, so like the more accurate the sensor is, the higher is going to be the accuracy and the reliability. So this part is very attached to the instrument you're using to measure or obtain the data. How fast you update the data from the time you measure it to the time you publish. So for example, if I measure a data 10 years ago and I publish it today, then the quality of the data is not that high because it's something, from 10 years ago. The accessibility, how easy it is to find and to download the data. The usability, like how useful that data is through time, through region and domain. So like for example, some data sets have like 10 years of data and you still use it 3 years after the last are still useful because you have a long-term data. And the coherence, and this is very related to the accuracy and reliability, and it's what methods you use to gather data. So for example, if you're measuring the temperature in the city, right, if you measure 100 meters up or if you measure like 5 meters up from the street, you know, it's going to be different. So like what method you use is going to be very important in determining the data quality. So from an overview of what data is, you know, we enter like what spatial data. And spatial data is just one type of data. And the spatial data is basically all data is collected somewhere. And if you keep where that place was measured on, then basically you have spatial data. So spatial data is going to have two components, or two main components. The first is going to be the location, right, which is going to give us the spatial component, and this is like the coordinates of where you are measuring the temperature. And the other is the attribute, or the measure of the data itself, right? So you have what you're measuring and the place where you measure. And anything can be spatial data as long as you keep that location. For example, if we can track all the phone calls and we keep where they're originating from, right? And then we have spatial data about originating phone calls or the credit card use, right? If you process your credit card in a cafeteria here, and then the bank can know that it came from this exact location, right? Then that's spatial data. If that location is eliminated and you just have the transaction amount, right? Then that's financial data. So here we can see different type of spatial data. Like the most common is just finding locations in a map, right? And the first one in this part is like hospital locations in Sofia. So I just looked in Google and I wrote hospitals and that came out, right? And this is like the most basic. It's like this type of places are in this place, in this exact place. And then with that information you can create maps, like route map, right? So for example, I've been here a couple of days only, but with this information I can go from the Sofia airport to here, right? So it tries a route and it can figure it out because it already knows, like for example, that that's a street and that street is one way or two ways, right? And then with algorithms it can figure out the best route through cars how to get there. On top in this part we can see a noise map. And basically what they did is that they were measuring the level of noise at different places. In each place they have two information. They have like the noise level and the coordinates of where they are measuring that noise level. Right? And in a map then they put all those dots with a measurement and then they try to extrapolate with knowing how, let's say, noise propagates. And then they try to estimate all the other points that they didn't measure, right? And it becomes a noise map. And then you can also do what are flood forecasting, where you try to know, let's say for example you have a river, right? And you know that in certain part, if it rains a lot, it means that in the down part it's going to flood, right? So if you have information of how the river is going and you have information of the amount of water that is coming, then you can predict what's going to happen in a couple of minutes, in an hour, in a day, down in the down of the river, right? And this is also spatial data. And these are just examples, right? But there's much more things that are spatial data, or things that you can do. And when we talk to spatial data, there's basically two types of data, what is called raster and vectors. Right, and rasters are better for continuous field, and the variable used has a finite number of options, and each possible position is defined by the value of the variable. So this is more like a grid style, and the size of the grid is going to impact how accurate the presentation or the value is going to be. And this is good for presenting, let's say, variations and smooth a variation in a place. So for example, you want to see like the data map, the noise map, you can use like a raster type of data. And the vector is more for discrete objects, and it needs well-defined boundaries and empty space, and it can express a series of tables. So to make it a little bit more visual, this is vectors, and these are rasters. So like vectors, you can create more fluid, like smooth transitions, because you can point different objects. But with the rasters, you have a grid, and basically you have to fill the points in each grid. So if you know how to, like a monitor works, you know, you have pixels, right? So like each point in the grid is like a pixel in a monitor. You have to fill the color, right? So it's easy to go from so if you have vectors, you cannot mix it with rasters, right? Either you work in one or you work in the other, but you cannot work with both at the same time. So computationally speaking, it's easy to go from vectors to raster, right? To convert from one point from one data type to another. But from raster to vector is more difficult, because like in rasters, you have it will depend a lot on the size of the grid and the size of the pixels. But computationally speaking, going from raster to vector is much more difficult. So once you have all that spatial data, right, then we have what it comes Geographic Information Systems, right? And these are basically computer software that help us analyze and understand what are spatial data, right? And the input of those systems are basically what are spatial data. So they're useful for determining spatial relation, like what happens where, and in different phenomena. And it helps us link spatial patterns to process. And there's like a very famous quote that says, everything is related to everything else, but near things are more related than distant things, right? And this is what basically is what it's telling us is like, we can find information about what is happening, and the closer they are, then the more impact they have, right? And with the use of GIS, like we can help, like we can develop those type of patterns. But we have to think that GIS is much more than just mapping, right? Like mapping is geography, right? Right? But GIS is like trying to understand the things that are happening on top of a map or you know, so in GIS the data has to be related to process regarding data acquisition and manipulation. So this is something very common in all fields of science, right? What you're trying to understand has to have a theoretical background, right? And you have to have a reason how you gather the data. It's not like you're going to put a sensor like here and say you're measuring the temperature in the university, right? No, this is one classroom. You know, so we have to have a process on how we're going to gather the data, how we're going to analyze the data, and what type of information, when we see the information, how we present it, you know, it has to have like a reason why we're doing that. So the data, right, has to have a process of acquiring the data, and the analysis has to be related to a model, right? And that is very common in all aspects of science. So when you have multiple GIS working, right, and you want to bring them all together, then you have something that is called spatial data infrastructure. And this is how you combine all the different GIS, all the work, all the data that is being poured in or out of GIS systems, right? So if you put them all together, then you have what is spatial data infrastructure. And what we were talking in the beginning, when we were talking just about data, and we were talking about the data catalogs and how you connect all the different data catalogs, basically as an SDI is that, but for spatial data. right? And then this creates the framework that allows for the different technologies and the policies and institutional arrangement to combine and share the data, spatial data. So it improves the means to automate the process of posting, discovering, evaluating, and exchanging spatial data between different actors. And imagine, let's say that you have a ministry that can produce a map of the whole country, right? And then you have, let's say, the energy ministry that wants to put where every power plant in the country is, right? If they cannot access the map, they have to build it themselves. But if they can access the map, then they just have to figure out where each power plant is. And then maybe you have somebody else who wants to see like where all the hospitals are and how close they are to the power plants. And maybe there's a meaning in that. So like if we're able to share all this data, first we have to have an agreement on how we're going to share all that data. And that's what the spatial data infrastructure facilitates. And this is an initiative that is being taken by the European Union, the United States. Like the European Union has the Maestra initiative, and basically it's developing an SDI for the whole European community. But for that to happen, each individual country has to have its own SDI. And that means that every institution has to have their own GIS system. And then this creates the framework to make sure that all of those can work together. So how all of this relate to a smart city? And this is where we wanted to, my main talk was about. So a smart city is basically the integration, a city itself has multiple services and systems that have to work together to provide to the people who live inside the urban space. Right? For example, in Sofia, you have electricity, you have water, you have transport, you have garbage collection, right? All of those are systems or services that are being provided to everybody who lives in the city, right? So a smart city, what it does, it uses technology to make those systems more efficient, right? It uses technology, it uses the social and economic capital of the people who are there in that urban space. And what it makes is try to make everything more efficient through the use of ICT. Right? And if we're using ICT in an urban space, right, then we have to have information about all the places inside of the city. And that information is a spatial data. Right? So a smart city is going to work if all the systems can integrate and can interchange data between each other. Right? And then this is what is a spatial data infrastructure. So for a smart city to work together, you have to have your own spatial data infrastructure so that each individual system has a framework of how to share the data, how to use the data, and how to give it back to not only those systems and services of the city, but to the people, right? Because maybe you want to know, right, when the bus is passing, or you want to know when the garbage truck is going to collect the garbage, because you prefer to take the garbage out the day that it's going to pick it up and not just any random day. So when we see all the aspects of a smart city, right, we have smart grid for like, if you're using renewable energy and you have solar panels on your rooftop, you might inject electricity back, or maybe you want to consume from another part. You have what is smart agriculture, Internet of Things, smart health, big data, like smart education. You want to be able to create an ecosystem where anybody can, with the data being produced by the city, can produce some economic value or social value, because not everything is money. Sometimes you want to create something that is going to be useful for your citizens, even though it may be not producing money itself. So, for a smart city to work, you have multiple information systems that need to interact between each other. And most of those systems are GIS systems. So like those are what we think are smart cities. or from the point of view that we are looking at smart city. So in this aspect, we have 4 projects running in my university and that I am working on. And the first thing is that we are defining what the Dominican Spatial Data Infrastructure is. And this is something we're working with a National Geographic Institution, because they are, so this is not something from my university, something that we are working with the government, and it's for the government to develop this, because the government is going to be the one who's going to define or administer how all the institutions, both governmental and non-governmental, are going to share the data. So what we're doing is we're helping them define what are the Dominican metadata. And what we're doing with this is like when you publish a data set, what are the metadata that are required to be filled to be able to publish in that spatial data infrastructure. So this is, if we see it from a technical point of view, this is not difficult to do. But we cannot go and say, these are the metadata. We have to make a consensus with all the different actors, and we have to make sure that everybody agrees. So the difficulty of this is not in the technical aspect, but in the political aspect, that you have to make everybody agree, because they are so big that you cannot force them. You have to make sure that they want to. And then we are helping them in the system requirement for hosting the data sets. And this is a technical aspect. From another point of view, we have a real-time interactive noise map that is being developed. And what we're doing is we are deploying a network of sensors that can measure noise level at different points. So we have more than 52 noise level sensors deployed in this is called a colonial zone. And this is, anybody know Christopher Columbus? Like, he was the one who got to the New World first, right? So the first place that they built was there, in that city. So like that was the first city of the New World. So we have some like important human heritage, right? So and it's like perfect because it's not so big. It's like roughly 1 square kilometer. So it's not that big, right? So we can measure the noise level. We are a very noisy people, a noisy city, right? So the government is trying to reduce the noise level. But what we argue is that sometimes we make policies, but we don't know if those policies are working, right? Because we're not measuring what was happening before the policy or what is happening after the policies, right? So if we don't have data, then how do we know that what we're doing is correct? So for example, if you take an exam and the teacher never tells you your grade, you don't know if you did good or bad, right? So that's data, right? And this is what we want to predict. Like, we have an urgency to reduce the noise level, especially here. So we're deploying a real-time sensor network so we can read the noise level in real time. Like constantly read the noise level and put it in an interactive map. This way we first know where we are at, once the policies kick in, if they're working. And then we can try to see, like for example, if you want to make a hospital here, right? You're not going to put it where the most noise is, right? You have to figure out where the least noise is. So this is something that is not only going to help like check if the policies are working, but if you're building something, you can, let's say, put enough insulation regarding to the noise level where you're at. So this is our first step of this project. And right now we're just deploying the sensors, and we're checking if they're working. And the next step would be to create that map. So not only that the government can access that map, but that anybody who lives in that area or anywhere in the world can see the noise level. So for example, maybe you want to live there, right? and you're looking for a house, but you have young kids and you don't want to go to a noisy house, right? So there you can see not only what's happening at the moment, but as long as we install, since the day we install the sensor, you can see how the noise behaves. So you can have better information. So once we have this project working in this area, what we expect is to expand it to the rest of the city. So this is more like a pilot project. A different project that we are working on right now as well is something similar, but instead of noise, but with air quality. We still have a lot of factories in the city because the city of Santo Domingo grew without any proper planification, right? So some urban spaces, they were developed right next to a factory, and maybe the factory's been there 100 years, right? But then that is affecting, because they are producing something and they're affecting the air quality of the people who live there. Right, so we are, in that same sense, creating an air quality map. This is a little bit more complex because the sensors itself, because as we measure, to assure the data quality, we have to have good sensors, right? And to have those good sensors, they're very expensive. And they have to be calibrated every 6 months. So we started with 2 sensors, but that's not enough for mapping the whole city. So what we're trying to do now is to show the utility of those 2 sensors so that we can buy more, plus we can have enough funding to calibrate all those sensors every 6 months. And finally, the last project we're working on regarding this type of is electric vehicle charging infrastructure. So basically, electric vehicles are the future, right? And everybody is betting on them. But to be able to have electric vehicles running in a city or anywhere, you have to have charging stations, right? If you don't have gas stations, you cannot have gas cars, right? So if you don't have electric vehicle charging station, you're not going to be able to have electric vehicles, because yes, you can charge in your house, but what if you go somewhere else and you're running out of battery because you forgot? Like I have a cell phone and sometimes I forgot to charge it and I run out of battery, right? But my phone doesn't take me back home. My car does, right? So I have to be able to find a place to charge it. So this infrastructure has to create a map where you can see all the charging stations where they're located at, right? But you also have to know if they're being used or not. And that's from the point of the consumer. But from the management point of view, you have to be able to measure the amount of energy that it has consumed. You have to be able to see the amount of the operation of the charging station. And this is all geographically located, so that's why it becomes a GIS system. And all these 3 projects, right, what do they have in common? They're providing a service to a city and to the people who live in that city, right? And these 3 projects by itself are not a smart city, and only these 3 projects are not a smart city, right? But they are contributing to developing what a smart city would be, or what Santo Domingo can be. And we cannot be the only actors doing this type of things. Like other institutions, other universities, they have to do projects similar to those. So, and then this is like what I prepare, and I don't know if you have any questions or.
Can you tell something more about the software? Because you said that you're using some sensors, but how are they connected? What software do you use? How are you already ready product.
So the
APIs.
Yeah.
And so on.
So the sensors, they have their own operating system. They are like embedded systems. So what we're doing, we are connecting, like we program those sensors. So they have a proprietary system based in Linux, right? So once you give them connectivity, what we do is we program them to a server in our university, and then periodically they just send the information to the servers. So like that's at the moment we are starting right now, right? And once the data is in the service, we're using basic programming languages like Python and R to create those maps. We are still in the deployment aspect, so what we're doing right now is we are connecting those equipments to a network, basically a LTE network, and then we configure their to the servers that we have, and then so that they can authenticate to the server, but that's basically as if you're connecting any Linux-based device. But for analyzing the data, or what we have done so far, we're basically using Python and R. And for this system, the charging stations, we are not developing them, right? We're buying the charging stations. And the charging stations, they use an open protocol that I forgot the name right now, but so basically it's similar. Like we just have to figure, like once they are connected to the network and we authenticate them, we can, like through the API of the charging station, because of the open protocol, we can just access all that information of. So the only thing we have to assign them is connectivity, like an identification, and then let them know exactly where they are positioned. Because since they're not moving, so like it depends on the charging station you buy. You can buy one with a GPS integrated, or you can just assign them like a location. So like this type of infrastructure, we are working with two private companies. One is a Korean company, which is called KEPCO, and they are like the main electric producer and distributor, and they have some experience developing the charging station in Korea. And ESD is the local Dominican company, and like what they are planning is that the infrastructure should work regardless of the charging station itself, or the brand of the charging station. As long as they support that open protocol, then they can connect to the infrastructure. So the infrastructure, like for example, if I buy one of those charging stations, then I could connect to the infrastructure. So like ESD and KEPCO would manage my charging station, and then they would pay me for cars that are not mine that connect to that station. So that's like the business model that we're working on. This is a project that we got the funding in January, so we are still like in the planning stage. If there's no more questions.
Yes, I think that you have done a lot so far, but there is still more to do. Because you have the sensors, you gather data, you store them, process them, analyze them, and the part of the sharing is also for the problems. You have more work to do, but let's see the projects that you have started.
Okay.